So we have a situation here where I want to make some money, and I've proposed this game of sorts. It's kind of like a little, you spin the wheel, you pay to play, and if you land on a certain color, you either lose money or win money, okay? And so I've kind of proposed this scenario, and I want to decide, am I going to make any money, okay? So I've got several colors. I've got one of the, 1% of the wheel that I have is designated black. 4% of the wheel is purple. I have white, green, and red that are each 15% of my wheel. And then the remainder of the wheel is yellow. And I have some payouts that I've kind of come up with here. I say if you land on that 1%, that black space, you're going to get $200. All right. And if I land on the purple spaces, okay, or 4% of the wheel, I get $50. $5 on red, green, or red, white, green, or red, and yellow, you get squat. But I'm going to make it cost $10 to play. Okay, am I going to make any money? Okay, let's figure that out. So what I need to do is to create a probability distribution that'll help me answer that question. And we kind of talked about this, and this was a lot of what your extra credit was, if you took the original test, was to create a probability distribution. But it was a little bit different. It was a binomial situation. Not that you know what that is yet. It was a slot diagram thing. This one's a little bit different. Okay? What I want us to do is I want us to decide what are all the possible outcomes. Let's do that first. Okay? So what outcomes can I have? I'm talking money-wise. How can I, maybe ask it a different way. How can I define X? What is X? X's can be the amount of money. We probably should define that. And I really always want you to anyway. But don't you agree, we'll come back to the defining part, don't you agree that if I get nothing, I have lost $10? Because it's costing $10 to play, right? What if I land, so that would be if I landed on a yellow space. Would you agree? What if I landed on a white, green, or red space? I'm going to lose $5. I agree. What if I land on a purple space? What's the outcome going to be? I win positive $40. And then what is if I land on that coveted black space? How much money am I getting? $190. Okay? So how can I define X? What really is X here? X is the amount of money that who leaves with? The player. Not Mrs. Mackert, because I'm the one trying to win the money, right? So we need to be very clear. You can put it on my desk. Who's getting the money here? And it's I've defined it in such a way that that's the amount of money that the player is going to get. Do you agree? So we need to say that. So this is the dollar amount the player wins. Be okay so far? It's very important that you're clear about that. Okay? It's like the net winning of the player. Bless you. So now what we want to do is we want to figure out their respective probabilities. Okay? And this is actually, in this particular scenario, is easier than the one that you had on your test for extra credit. If I know that 1% of the wheel is black, and I'm just doing one spin here, I'm not doing a number of spins, so I don't have to worry about a slot diagram, it's just one spin, isn't it just 0.01 is the probability? Okay, good so far. How about purple? What's the probability of me getting 40 bucks? 0.04, right, I agree. What's the probability of me getting, of me losing $5? Where'd the 0.45 come from? Say you're right. So it's you either get white or green or red. So you're just adding all those together. So you get 0.45, right? I agree. It's not and, it's one or the other. With one spin, you can't land on all three. All right, how about what's the probability of me getting a yellow? Because up in the problem, it just says the rest. It's 0.5, because Angelica just said that you know that all the probabilities have to add up to 1. So right now, if I added what was already here, I'd have 0.5. Subtracting it from 1, that means half of the wheel is yellow. Okay? Any questions to where the probabilities came from? Okay. So once I have this created, what I'm looking for now is the answer to the question, will I make any money? I have the likelihood of me getting, or the person winning $190 total, or the person winning, losing $10, but how do I answer that question? There's a calculation I have to do. What is it? What did you do on your test for extra credit? Yeah, it's an average. It's the expected value. It's how much money. Will I make any money is really another way of asking what is the expected value here? What's the average? On average, how much money per spin will the player win? Another way to ask the question. So let's do it the long way for a minute. How do I find the expected value? We'll use a calculator in a minute, but how do I do it with just a probability distribution? Who remembers how to find that? Crickets. Yes, love? Sure. Yes. It's going to help me answer that question. It won't be the answer, but it'll help me answer it. Negative 10 times 0.5 plus. Good job. Keep going, Angelica. Perfect. Good. Good. Why don't you go ahead and do that for me? I'm going to pause the recording. Find that calculation. Tell me what the expected value is. Did you get negative 3.75? Okay. Good. So what does that mean? Will I make any money? Yes, I will. So here's why it's so important for you to decide what X is. X is the amount of money the player wins. The player is losing money. Guess who's getting the money? Mama Mac. Okay? So that's why I really want you to define up here what's happening, because if you don't, you're going to get fuzzy, okay? And I don't want that. Be very clear. So will I make any money? You bet your dollar. So let's write a sentence. Let's write a conclusion that answers the question. The question now says, on average, because this is an average, right? And I showed the calculation, Mrs. Mackert is going to make how much? Yep. We'll make $3.75 per spin. Now, does that mean every spin I'm going to get out I'm going to get $3.75 from each person? No. Some people will get the $190. Some people will only lose 5. Some people will win 40. Most people will lose 10, right? That's what that's saying, really. Here's a different question. How much should I charge? Let's say that I'm feeling really guilty about taking my students' money. It's probably not appropriate. Maybe I'll get fired. Maybe that's a bad idea. Okay? Of course, I'm being facetious. But how much would I need to charge in order for it to be a fair game? This means that I'm really not trying to make any money. Huh? Say what? No, you wouldn't play for free. I'm still going to pay out money to some people. No. I originally charged how much? $10. So I should charge how much? Nope. I should charge $6.25. Where'd that come from? Okay. if I initially charge this and they're losing $375, if I only charge $625, wouldn't on average now they're not going to lose any money? Does that make sense? Okay. So that would be how much I would need to charge to make it a fair game. Okay? How do you feel about that? Maybe? We should try another one, don't you? Make sure we understand. Okay? Make sure it's clear. Let's try this one. This is a little bit different. Now I'm not spinning a wheel. Now I'm going to be drawing from a deck of cards. And I'm just going to draw one card. I'm going to mix them up, shuffle them up real good. Make sure that I've shuffled. And I am, made this too big apparently, going off the edge. There we go. What do you think? Let's start with what the expected value is. Okay, we'll get to standard deviation in a minute. What should we do to answer the question? Okay. Expected value of the game for the player. We're going to define X as how much money the player walks away with. So we should say that. So let's come up with all of our outcomes. What are those possibilities? What are the outcomes here? How much money can you win? Are you ever going to lose any money? It costs $5 to play. So maybe it's a chance that you lose your $5. We'll come back to that. Is there a chance to get $0? You pay $5 and you win $5, right? So wouldn't that be 0? You break even? What are some other possible outcomes? Plus 5. And then the other one would be, I'm sorry, 95. Would you agree with that? Okay, it's just how I've defined my variable. Let's write underneath of those what each of those are. So if to win $95, that's really the ace of hearts. Do you agree? What's the probability in one regular standard deck of cards for you to get an ace of hearts? How many of them are there in a deck? Well, there's one ace of hearts in a deck of 52. Good. I agree. Okay. What's the outcome to win $5? So any other ace, right? Because any other ace means that I've paid 5, but I win 10. So it's a net of $5, right? So how many of those are there? We have the ace of diamonds, we have the ace of clubs, and we have the ace of, oh gosh, the spades is my hardest. Okay, pretend. It's upside down heart. I like that. I'll do that from now on. How many of those are there? There's 3 of them out of a total of 52. Good. All right, let's keep going. Next it says for any other heart, how many hearts are left? I've taken care of the ace. That's the grand poobah, right? That's the big deal. How many other hearts are there? There's 12 of them. You have the 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts, 7 of hearts, 8 of hearts, 9 of hearts, 10 of hearts, Jack, King, Queen, right? There's 12 of them. So 12 out of 52 would be all other hearts. Agreed? Yes, sir. This is only drawing one card, so I don't have to worry about replacement. But that's a very good question. If I was drawing 2 cards, I would have to answer that question, wouldn't I? We're just drawing 1 card. Do I know that there's supposed to be because it doesn't say anything in here about losing $5. So we're assuming that that was an option. How do I know it definitely is an option? Because there's other cards you can get, and that's one thing, I agree. You can get any club or any other club besides an ace, any other club besides a, okay. How else do I know? What are the probabilities? What should they add up to be? And what do they add up to be now? Not 1, right? So I know we're missing that. So this is like all the other cards. Would you agree? So this is going to be all the diamonds, all the clubs, and all the spades. Okay? Except for the aces. Do you agree? So that would be 2 through king of each of these. Does that make sense? How many of those cards are there? How'd you get that quickly? You're exactly right. 12, okay, 12 times 3. That's an easy way. I did it differently, but I like your way better. Okay, so it's 36 out of 52. I just said that it was 16 in the numerator. It should add up to be 52. 16 plus 36 is 52. Same thing. 2 different ways to get the same answer. Okay. Because I knew that all of these had to add up to be 1. So right now, in other words, 52 over 52. So right now, 1, 3, that's 16. How many more to get to 52? Or James did it differently. He said, if I know that I have 12 diamonds, clubs, and spades, 12 times 3 is 36. All right, what's the expected value? What would you do? How much is the player going to take home? Well, we can do it long ways. -5 times, 36 over 52, 0 times, and go forth. What's the short version on the calculator? Stat, edit. You tell me. So we got to clear out what's there first, right? And what goes where? Right, all the outcomes or all of our expected outcomes or how much the people are going to win goes in list 1. And then all of the probabilities will go into list 2. It is okay to type them in as a fraction like this and hit enter. It'll come up as a decimal. And it might round for you, but it's not actually rounding. It's just displaying a rounded answer. So it still knows it's 36 out of 52. Okay? And then we have 12 out of 52, 3 out of 52, and 1 out of 52. Okay? Now what? Stat, calc, one of our stats. Now my operating system is older than yours. When you do, and you should all be doing, stat, calc, one var stats right now, what window comes up? What's different about your window and my window? The frequency is, well, you need that frequency list. So what are you going to put in terms of your frequency list? L2. So with my old operating system, I just go L1 comma L2. But you'll put in list 1 as the actual list, and then your frequency list is list 2. You should get the same exact numbers I did. Okay? Yes, Lovey? That's exactly right. What number am I looking for here? For the expected value. The expected value. The X bar, right? The first number up there. So what am I going to say? $1.30, 35. Good. Okay? So my expected value here is $1.35. I agree. Okay? The next question is, what's the standard deviation? And we did that by hand before. Do you agree? Yes. So did I. Oh, I'm sorry, negative 1.35. Thank you. Yes, negative 1. And what does that mean in context, by the way? The player is losing money. Not as money. I'm winning. I'm good. I got a whole $1.35. On average, right? On average. What's the standard deviation? What number am I looking at here? The little O thing with the tail, it's called a sigma, okay, yeah. And it's, normally we use the S, but it's not provided here for us because it's a different kind of calculation. So we will use the population standard deviation, which is 13.80. That seems awfully high. What is standard deviation a measure of, by the way? how far away from the mean, right? It's a measure of spread. Remember we talked about this back in the very beginning of the year? Do I expect the spread to be really high like that? Why? Because only one player out of 52 people are going to get, or you have a chance of 1 out of 52 to get that $95, where most people are going to lose their shorts, right? Or at least $5. So I expected there to be a big spread, absolutely. Okay, good. So your homework is going to be from chapter 2, I'm a liar, chapter 15, okay? And it is due on Thursday, and it is problems 2 through 10 even. It is only the 5 problems, some of which the probability distributions provided for you. Plug it into your calculator, get an answer. Not hard. There are 2 problems you'll have to do what we did in class. You'll have to come up with the distribution yourself, okay? So only 5. 3 of them is just a calculation on a calculator. 2 of them is your own work. Due Thursday.